Tom, we have an interesting question from Pete. The debate today is if the Earth is flat or round. Is this question valid since it's really a digital Earth based on a rule set anyway?
Well, I'm not sure how to answer, is it valid, but it's really not very important. I could say that. And here's why. This is a virtual reality. It's computed. So whether you see it as round or flat, if you make up a scheme that works for you, is really not all that relevant. We're here to grow up, to learn, to get rid of our fear and become love. And if you can learn to let go of your fear and become love in a flat world or a round world, just the same, then it really doesn't make any difference how you see it. Now, the rule set that we have defines this virtual reality, right? Everything that the rule set says is the rules basically constrain things to be the way they are. Okay. Now, given that, it is possible to look at things from different viewpoints. Now, let me give you an equivalency. There was a time when people thought that the Earth was the center of the universe, right? God created the Earth, then He created everything else, right? And here we are on the Earth, center of the Earth. Now we grew up, got telescopes, and said, "Oh, look, there's a bunch of other stuff out there too." Well, we must be at the center because God created us first. So the Earth was seen as the center of the universe. Now, you can take a three-dimensional map of everything in the universe, right? That means that you have a coordinate system somewhere. You have located an origin. And then with that origin, you can locate everything in the universe. Now, they did that with the Earth and just our solar system. And you can get all the right answers if you make the Earth the center of our solar system and you have the sun going around the Earth, the moon goes around Earth, all the other stars go around the Earth, and so on. You can do that, but the math gets really complicated, and you have what they called epicycles. So the cycles that the planets made are these kind of little curly Q things where they actually go backwards for a while, and so the math gets really complicated. But then if you take that origin and say, let's stick the origin at the sun, oh, then all those orbits that were going around and going forward and backwards, they all turn into ellipses. All the planets are just ellipses going around the sun. Nice, clear, simple mathematics. So either one is okay. Either perspective, if you say, well, one's the right perspective, the other's the wrong perspective, that's really not true. Either one is possible. See, you can take the origin of a three-dimensional coordinate system and place it anywhere and still explain the motion of everything in the coordinate system. It's just that if you make it some places, those explanations get simple and easy. And you put it other places, and you can still describe all the motions, but they get to be really complex and goofy and move in all kinds of strange ways. That's very hard to explain. Whereas if you put it, let's say, at the sun for our solar system, if you put the coordinate at the sun, suddenly the mathematics describing all the various orbits gets simple. And a very simple concept can explain them, the concept of gravitation. Okay, so now you have a simple Newtonian gravitation, which says that all masses attract each other. And they do that according to, it's a constant, they're proportional to a constant times m1 times m2 over r squared being the distance between the centers. So that's the formula for it. And with that simple little formula, you can describe the motions of all these things. Otherwise, there was no simple way to describe them. They were just totally undescribable. There wasn't any simple way that you could say, oh, yeah, then this thing does a loop-de-loop and goes backward for a while and then goes forward. So the way physics evolved, it evolved with this concept that the simpler the better. So it'll always take the simplest of all the possible viewpoints. Now, the Earth being the center is one possible viewpoint. And it's not wrong, it's just different, but it's very complicated in then trying to compute everything else. Whereas if the sun is the center of our little solar system, then everything gets simpler. And we can just take a simple little proportion called gravity, G m1 m2 over r squared, and poof, just that little equation describes all the things going around in our solar system and describes them very accurately. So science says, we'll take that one, the simple one, and that will be the one that we will say is kind of our standard model. But it doesn't mean the others are wrong. They're just not as useful. Okay? And that's called Occam's razor, which says the thing that requires the fewest assumptions, the thing that is the simplest and most elegant solution is the truth. That's more likely to be the truth. And that doesn't mean that everything else is wrong. It just means that everything else isn't the best way to model it. It's not the best way to think of it or conceive of it. Okay, so let's take that and let's say that somebody could conceive some way that this is a flat Earth. I mean, there's lots of evidence that says it's not, but let's say you can just make up stuff. You can make up enough rules and enough explanations for things that you could say this is a flat Earth. Okay, fine, you can do that. And I would even go so far as to say that's not necessarily wrong. We'll just call that different. Let's say you were good enough that you could explain everything that way. But it would be very complex. You'd have to have all kinds of other assumptions, assumptions that explain satellites orbiting the Earth and the Earth orbiting the sun and all this other stuff, because you wouldn't have gravity the way we have it now, because that wouldn't work that way. When you have gravity, then things tend to turn into spheres. If you take a drop of water in a place where there are no forces, right, no gravity, well, that means you can make a little place that doesn't have gravity. You can simulate that by going up in an airplane and then just diving down. And as the airplane falls down, within that space of the airplane, it looks like there's no gravity. Well, if you take an eyedropper and you squirt out a little drop of water, what'll happen? Oh, it'll go like this. It'll go, and eventually it'll settle down into a sphere. And if you blow on it, then the part that you blow will become like a head, and then it'll have like a tail going out behind it, because that's the air has forces on it, and it streamlines it out like a raindrop. Okay. So that's just an idea, the forces on things. But if there are no forces on things, things turn into a sphere. That's because there's a thing called adhesion and cohesion. The water molecules have cohesion forces that hold them together. Those forces of cohesion pull them all together. Okay. Now, the forces of adhesion would be the forces that the molecules of water stick to something outside themselves. Okay. So now, if you just have a water droplet in a vacuum, no forces on it, no gravity, no forces, those cohesive forces will pull it all together and you end up with a sphere. So things like molten planets and suns that are mostly squishy, they're not really solid. They're like the core of the Earth. It's really squishy. It's molten rock. It's liquid. And the sun is mostly just like that. It's liquid and gas and stuff. You don't go into the sun and find mountains and rivers and streams. It's just this big furnace, big nuclear reaction going on in there. So it's like gas, liquid, kind of a plasma thing going on. And it just comes up into a ball because that's what these things do. The forces of cohesion pull things up into balls. And then you end up with spherical stuff. If there's a lack of forces, and out in outer space, where you're far, far away from any other thing, there's a lack of forces. There just aren't any forces out there. That's why you get out there, there's no gravity. It seems like because you're so far away from the nearest other mass that all the forces of gravity pulling on you from all the other masses in the universe amount to nothing, because they're so small because of that divided by r square thing. The further you get away from it, the smaller the force is. So anyway, that is our rule set. You know, that GMM over R square, well, that was Newton's best guess at the rule set for gravity. We have these rule sets. And the rule set seems like it most simply describes a spherical Earth with a spherical moon and a sphere. And when I say spherical, I don't mean perfectly spherical. You know, none of those things are perfectly spherical, but they're sort of roundish, let's say. A roundish Earth and a roundish moon and a roundish sun and roundish stars and roundish planets and things, because cohesion forces pull things together. They stick together and they pull themselves into little spheres because that's equal forces from all sides and it all pulls together in a sphere. So that's just the nature of things. Now, what does it matter? All right, well, it matters very, very little. So you can make up a flat Earth description if you want to. You can just make it up so that it precisely describes everything in the universe and you're happy with it. But you'll probably need a lot of assumptions and a lot of little things you'll have to make up to prop up that theory, because it's not elegant and it's not simple to do that. But you can do it and let everybody have their own way. I say, you know, why argue about something that is really meaningless? That's not what is important here. Whether you can come up with some kind of construction that's flat versus a construction that's round, make up your own kind of crazy gravity that pulls things flat instead of round, no problem. You know, march on with that. That's okay in my book. But so what? That's not anything important. That's just the rule set. That's what the rules say can happen here. The rules define all the possibilities and they define all the things that aren't possible. That's the rule set. We've got just this one rule set, but you can pretend that rule set says one thing or another. And if you put up enough structure around it, it's maybe even credible. In small ways, it'll make sense. It makes enough sense. But what's important is you growing up, changing who you are, becoming love, caring about other people, sharing, not fighting over whether the earth is round or flat, not getting angry and upset because some people call you stupid. That is part of the problem. So if you can have your ideas and have them peacefully and not get in arguments, not get angry, not get upset, not think that all the people that disagree with you just don't understand. And that's from both sides. If you're a rounder and you think the flatters are a little goofy, well, if you're arrogant about that, then you're not growing up. That's a problem, just as much as it is if you're a flatter and the rounders think you're stupid and you think the rounders are stupid, and all of that is dysfunctional. So make up your stuff that suits you, because it's not important. It's mostly irrelevant. And then live with it, but live with it gently and let other people have their opinions. And you don't have to, it's not a fight to the death. It's not something to struggle and get upset about and cause anxiety and think that other people are arrogant and wrong because they don't agree with you. And that's true from whichever side you're on. There's no point being upset with people who are flat earthers and saying they're wrong. Yeah, but you're just wrong. You know, you're being stupid. Look at this data. Look at that. I mean, there's no value in that.
And it applies to other things as well.
Yes, it applies to everything. There's no value in these arguments. Let
As
people
long as it
be.
doesn't harm
Right.
anyone.
If it's not hurting anybody,
It's not
leave it
hurting.
alone. Take other people's opinions with respect. If you get angry because I disagree with you, now that's a problem. Or if I get angry with you because you disagree with me, that's a problem. So that's really the solution, is it doesn't really matter. Let people live in any kind of geometry that makes them feel right, that they believe in. Okay, no problem there. Just respect everybody and respect other people's opinions. Don't be arrogant that your opinion is the right opinion and everybody else needs to be educated by you until they agree with you. That's called arrogance. And it isn't helpful no matter which side it's on. And okay, maybe from your viewpoint, they're terribly confused. And maybe from all that you know about physics, all that I know about physics is this is a roundish kind of place because gravity makes it that way. It's just the function of gravitational fields. When you get out there where all these masses are so light years apart, the gravitational fields are close to zero. So what happens is they don't go this way or that way. They just kind of wad up into a ball because at the molecular level, there's cohesive forces and they tend to wad up, not flatten out. Now, that's the rule set that I understand. But if somebody else says it different, okay, unless that somehow makes him park sideways in my garage or do something that hurts my life, then why should I really care if it makes him happy to get that way?
It's interesting, isn't it? Well, this has been
Yeah.
a very interesting answer. Pete, thank you very much for your question.
I and MBT Events hope you liked this video. We will continue to post videos for free on my YouTube channel, but please understand, these videos are expensive to produce. They represent many thousands of hours of production and editing, as well as all the necessary audiovisual equipment, computers, and software. If you find something of significant value in our videos, please consider supporting their production through our Patreon account or through a one-time donation. It would be very much appreciated. The links are in the description below. Thank you.